Hello, thanks for clicking. Welcome to another Prenarculus production. Today we're going to be talking about the difference quotient, which is a very important concept that you will use in calculus. Okay, very important. We're going to talk about it, how it works. It's actually something that you know about. You're well aware of it. All right, but we're going to take it and kind of put it into a general form, which makes it a little bit more difficult. All right, so let's get started. So, what is that difference quotient? The difference quotient is a way to measure the average rate of change. But average rate of change is just a fancy way to say slope. Now, we know how to find slope. We've done it many times. y2 minus y1 over x2 minus x1, or delta y over delta x, right? Change, delta means change. Change in y over change in x. Okay, these two formulas are the ones you're most popular or most familiar with from algebra. All right. So the difference quotient, again, is something you need to be able to algebraically work with because in calculus, you're going to have to do it, and it has much greater meaning there. So here is the difference quotient that we are going to calculate here. There's actually two versions of it. We're going to learn both. So the difference quotient we're going to calculate here is f of x plus h minus f of x over h. Okay? Which you might be saying, well, it's y2 minus y1 over, there's only one thing in the denominator, right? So what really this came from is it came from this, y2 minus y1 over x2 minus x1. That's how we ended up with just h in the denominator. These two x's ended up canceling out. Okay? So the goal behind the difference quotient is very simple. Every problem works exactly the same. The goal is to get this h that's in the denominator to cancel out. So you're going to evaluate the two functions on the top, and then you're going to do some algebra, and hopefully this h underneath will cancel itself out somehow. All right? All right, so let's try a few, and we'll make sure that we know how it all works. So I want you to calculate the difference quotient for this function, f of x equals 3x plus 5. All right, so we're going to do this in steps. Okay, I think that's the easiest way for everybody to understand it. So the first thing we're going to do is we are going to calculate f of x plus h. That's what this part of the formula is here, f of x plus h. We're going to calculate it. Now, to calculate f of x plus h, we're using our function f of x is equal to 3x plus 5. All right. Now, what we're going to do is we're just going to replace all the x's in f of x with x plus h's. In place of x, you're going to put an x plus h. So I'm going to write it down. So I have a 3 here. In place of this x, I'm going to put an x plus h. Okay, and then I'm going to put a plus 5 because that's all part of f of x. And this is f of x plus h. Now, I'm actually going to multiply this out. Okay, I'm going to distribute the 3, it gives me 3x plus 3h plus 5. That is my f of x plus h. All right. Now, if you didn't understand this step, x to x plus h, think about it this way. If I gave you f of x equals 3x plus 5, and I said find for me f of 2, well, you just put 2 in wherever you see an x, and then you try to clean it up as best you could. You'd end up with 11. Right? So replace the x's with 2's. Now I'm saying replace the x's with this fancy x plus h. Okay? So that's step 1. All right. This is what we need. Okay, now the next thing we're going to do is we're going to use this formula that we have here. F of x plus h minus f of x over h. And we're going to start plugging things in. So f of x plus h, we just found 3x plus 3h plus 5. So in place of f of x plus h, I'm going to write 3x plus 3h plus 5 minus f of x. Well, f of x is up here, 3x plus 5. So in parentheses, I'm going to put a 3x plus 5. And then the whole the denominator is just h. Remember, the goal is to get this h that's down here in the denominator somehow to cancel out using some algebra, usually that you do on the top. All right, so now, what can we do with this? Well, we can distribute the negative to each one of those, right? So that gives me 3x plus 3h plus 5. Remember, I'm trying to get that h in the denominator to cancel out. Minus 3x minus 5 over h. Well, okay, now the 3x's, they go away, and then the 5's go away. So now I'm only left with 3h over h. So now the 3 and the h are multiplied on the top, and there's just an h on the bottom, so these h's would cancel. That's it. That's the goal. That's what you want to do. So the answer is 3. Now this 3 has an important meaning in calculus. Okay, very important meaning. So that's the reason why we need you to be able to calculate the difference quotient here, because in calculus, this 3 will have a lot of meaning to it. All right, so I'm done. All right, let's try one that's a little more complicated. So now we'll do the same thing, but f of x is 3x squared minus 4x. Okay, so step one, we're going to find f of x plus h. So now remember, here's my f of x. It's 3x squared minus 4x. Now I'm going to replace all my x's with x plus h's. Wherever I see an x, I'm going to put an x. There's an x. I'm going to put an x plus h and put it in parentheses. Minus 4. There's another x. So I put another x plus h. Okay, now I'm going to start foiling. I'm going to start multiplying this out. So that's 3x plus h times x plus h. And then I could distribute this 4 to each one of those. Minus 4x minus 4h. Okay, now I'm going to double distribute here, and then I'll multiply by the 3 when I'm done multiplying this stuff out. Because I can multiply in any order I want, right? 3 things are multiplied. You can do any multiplication you want. Okay, so we got 3x squared plus xh plus, this is hx, but that's just xh again, plus h squared, right? H squared. Okay, all that in parentheses, minus the 4x minus 4h. You can see that this gets really complicated in a hurry. Oh, I don't want to distribute the 3 yet. Let's add these like terms. That's good. So that's 3 times x squared plus 2xh. 2xh. Plus h squared minus 4x minus 4h. And now I'm going to distribute my 3. I'm going to distribute to all 3 of these. It's going to give me 3x squared plus 6xh plus 3h squared minus 4x minus 4h. And I can't do anything with this. None of these are like terms, right? That's an x squared, that's an x, that's an h. xh, that's an h, that's an h squared, that's an h. None of these are like terms. This is what f of x plus h is equal to, this whole thing. So I'm going to use this in step 2. So step 2, we come over here. I'm going to write down f of x plus h minus f of x over h. All right, so I'm going to do it underneath. F of x plus h is all of this. So in place of the f of x plus h, I'm writing this whole thing. So that's going to be 3x squared plus 6xh plus 3h squared minus 4x minus 4h. And then minus f of x. Well, that's f of x up there. 3x squared minus 4x. All over h. Now, the goal is to get this h to go away somehow. All right, let's see if there's any more algebra I can do. I can't combine any of these, but I can distribute the negative to both of those. So if I come over here, that will give me 3x squared plus 6xh. I'm just recopying everything that I already had there. One of the most common mistakes in this is that you copy stuff wrong from one step to the next, and then it doesn't work out. And then I distributed the negative to both of those, all over h. So now 3x squared minus 3x squared, negative 4x plus 4x. And I'm left with 6xh plus 3h squared minus 4h over h. So take a look in the numerator. I'm trying to get this h to go away somehow. I can't combine any of these, but there is a GCF. H is in all 3. So I'm going to take out 1 power of h. Take out 1 power of h all over h. And now these h's cancel. That's good. That's what I wanted to accomplish. So my final answer is actually an expression with variables in it. And that's okay. Sometimes that will happen. So my final answer, I'm going to write it up here on the top, is 6x plus 3h minus 4. That's my answer. And again, that's okay that it has variables in it. Sometimes it will. And then in calculus, you'll take the last step, and then that will tell you what it is that you're supposed to know. Okay? All right. Now, there's an alternate form of the difference quotient. So again, here's another way to write the slope. F of x minus f of c over x minus c, where c is a real number. Y2 minus y1 over x2 minus x1. So c is going to be a number this time, which sometimes makes this version a little bit easier to work with. Okay? X minus c will be on the bottom, and the goal is the same as it was a minute ago, is to get this bottom term to cancel out, the whole thing, x minus c. All right, you don't want to have the denominator anymore. Okay, so let's try that one. All right, so we're going to use the alternate form of the difference quotient, f of x minus f of c over x minus c, if f of x is equal to 3 over x and c is equal to 2. Okay, so first thing we're going to do is we're going to take 2 and we're going to substitute it into our formula over there so that we see what we have to do. So we have to find f of x minus f of 2, c is 2, over x minus c is 2. So the goal is to get this x minus 2 to cancel out. What we're going to do first is we're going to find f of 2. We can find that, right? We just take 2 and substitute it into f of x. So let's do that. F of 2 is just 3 over 2. Okay. So now we're going to go ahead and find f of x minus f of 2 over x minus 2. So f of x is your 3 over x. F of 2 is 3 over 2 over x minus 2. Now I have a complex fraction. So the goal, again, is to get this x minus 2 to go away. But the first thing I have to do is pretend that the denominator is not there, this x minus 2, because I need to combine these two fractions, right? 3 over x minus 3 over 2. The common denominator is 2x. Okay, I need them both in the common denominator. So the first term, it already has an x. It needs a 2 to make the common denominator. And the second term needs the x to make the common denominator. Okay, so that's going to give me 3 times 2. That's 6 minus 3 times x, 3x, over 2x. And that whole thing is all over x minus 2. That's good. Now I have one fraction on the top over one fraction on the bottom. I can put a 1 underneath there if I want. All right, so now I'm going to rewrite this in 5th grade style, x minus 2 over 1, so that I could keep the first one, change the second one to multiplication, and flip the other one over. Now, I have this. The goal is still the same. That x minus 2, I still need it to go away somehow. So I need to find an x minus 2 in the numerator to make that happen. Okay, so if I look in the numerator, what I have, there's a 6 minus 3x up there. Well, I could take out a GCF. The GCF would be 3. If I do that, I get 2 minus x in there. I'm going to leave the x minus 2 and the 2x separate from one another. I'm not going to multiply them because I really need this x minus 2 to go away. Well, these two are almost the same. They're not quite. I can't cancel it yet. But one's a 2 minus x. So if I take a negative out of the 2 minus x, take a negative 1 out, that'll allow me to switch the two signs around, right? So if I come down here, I'm going to take the negative 1 out, make that a negative 3. That allows me to make this positive 2 a negative 2, and the negative x a positive x. So I'm going to rewrite it as positive x minus 2 over 2x times x minus 2. Now I can cancel out the x minus 2's, and I get negative 3 over 2x. And that's my answer. Okay, again, I get something with an expression with a variable in it. That's fine. All right, and that's my answer. Okay, that's how you work with the difference quotient. All right, and we'll practice. And as always, thanks for clicking.